Welcome to a video on analytic geometry or algebraic geometry, and we're going to be talking about how to prove the perpendicular line theorem that says that the slopes of two perpendicular lines are equal to the product of the slopes of two perpendicular lines are equal to -1, or negative reciprocals of each other. So basically the idea is the slope of line L right here, we'll denote that m of L, multiplied by the slope of line K, m of K, is equal to -1. And or another way to say that is m of L is equal to -1 over m of K, right? And that makes sense because we can, from here, divide m of K out and we'd get -1 over m of K there. And that's just simple geometry, or algebra, sorry. So now with that in mind, we're going to go and start this proof. Now, I think the best thing to do to start this proof off is to use right triangles. And so first we're going to draw those. The best ones to use would be the ones that you generally use to find change in y over change in x, right? Because slope is defined as m is equal to change in y values over change in x values. So for line L here, the change in y values is a line like this, right? And the change in x values would be a horizontal line like that. A line that hit, L, line L. And we'd say that that's a right triangle, obviously. And we'd say that this slide right here is the change in x, and this is the change in y. But just for fun, let's give these points. Let's call that P. Let's call this E. Let's call this B over here. Now, to show K's slope with a right triangle, let's do this. Same situation. Here are the change in y values, and here are the change in x values. Just right to where the points are equal. The lines are equal, and let's call this A right here, and D right here. So right off the bat, we're going to want to realize that what the slopes actually are, okay? And so the slope of line L, m of L, is going to be equal to the change in y, which is PE, right? PE, over the change in x, which is EB, or BE, right? And so then the slope of K is going to be equal to the change in y, or AD, over the change in x, dP, right? So now what we really want to prove is that PE over EB multiplied by AD over dP is equal to -1. That's what we're going to want to prove, and I'm going to use, let's use green, section off a space here for that proof because it gets a little messy. Okay. First thing we're going to want to do is similar triangles. So obviously we know that these two angles are equal, right? Right off the bat, we know that ADP is equal to PEB, right? Because those are both 90-degree angles because they're right triangles. So now we just need one other angle equivalency to say that these two triangles are similar, and therefore that these two triangles have equal side ratios. And that's what we'll get to eventually. So what I'd say, I want to prove that angle angle BPE, this is just from me eyeballing it, I'm going to say that angle BPE is equivalent to angle APD. And if you see that, then you can skip forward a little bit, because APD and BPE right there. Now, how I'm going to prove that is basically say that I'm basically going to say that angle APD is equal to 90 degrees, because we know that this right here is a 90-degree angle, minus angle DPB, right? And this little inside angle right here, that interior angle, I can do it with a different color. This interior angle is DPB, and that all is equal to BPE, right? Because BPE is the same thing, right here. BPE is 90 degrees minus this little guy, right? So there's your angle equivalencies, and so we can just clear that, and we'll know that the angle-angle similarity, we have two angles similar, so all our side ratios are going to be the same. So we have triangle APD, the top one, is similar to triangle BPE by AA, right? That's easy, very easy. Now, section off this, so you just keep that in your mind while we prove the rest of it. So, first we're going to want to say that, again, we have our similarity ratios, right? So now, with similarity, we can easily say now that dA divided by dP is equal to EB over EP, right? Because look, dA, change in y, over dP, change in x, is equal to EB, change in x, over EP, change in y. They're flipped, right? Reciprocal. Makes sense, okay? And now we want to clean this up to get our -1 on the right side of the equation. So we're just going to multiply both sides by a -1, by a by a -1. Okay, and then we get easy negative dA over dP is equal to negative EB over EP. And now to get to our desired endpoint, remember, this times this is equal to -1. We're going to multiply by the reciprocal of EB over EP, which is EP over EB. So multiply by EP over EB, multiply here by EP over EB. Yeah, this all makes sense. EB. Now we have the EBs cancel out, the EPs cancel out, and we're left with -1 on this side. So our final equation is negative dA over dP multiplied by EP over EB is equal to a -1, right? And that's our final equation, and that's exactly what we wanted to prove, right? Look, EP over EB, EP, EB, change in y over change in x, dA over dP, change in x, right? Change in y over change in x is equal to -1. Multiply them together, you get -1, and that's our generalization proof on like the basic theory of lines, perpendicular lines. And I think in the next video I'll go through a proof on how to prove the inverse, how to prove that lines with negative reciprocal slopes are perpendicular to each other. And I'll see you in the next video.